Hello, hi, good afternoon everyone, and I welcome you all back to SISYA Class YouTube channel. Today we'll be learning integration as a part of our JEE Maths Foundation series. I'll tell you the basic things about integration. Since we learned derivations in the last class by Srikesh sir, right? What is derivatives tell about? They tell about small changes, right? Extreme small changes. Now what does integration talk about? Integration talks about this sum of small changes or sum of small terms, right? Let me introduce myself. I am Pawan Yashwant, a graduate in Bachelor's in Mechanical Engineering from Geetham, Visakhapatnam. I have 5+ years of experience in which I have taught over 20,000 plus students. So guys, let us define what integration is. Integration is a method of adding or summing up the parts to find the whole. If you see a curve, if you want to know the area of this curve, how can you find it? You don't have any standard formula, right? In these conditions, we'll be using integration, right? We'll take small areas and we'll add up to it. Hi, hello everyone. Hi, right? And integration, indefinite integration is a reverse process of differentiation. It's general that differentiation is the opposite process of differentiation. Let's talk about a graph. Let us assume you want to find the area here to here, right? How can you do it? Let us take small rectangles. These are rectangles, right? Now if you add this integral 10 to, let us assume this as 17, these are the limits. If you add these rectangles, you will get the sum, which is the area under this curve. The smaller these parts you take, the better the approximate answer would be. And these are the limits or the points from where your graph or the starting point is, and this is your ending point of the shape. This is a x square graph we are saying. Now this is the general form where f of x is integrand and this is variable of the derivative, variable of the integral. What does it say? This is with respect to what you are integrating the function with, right? And this is the standard form. There is a plus c for every integral of indefinite integral, right? Indefinite integral, you will be adding a constant, because while you're derivating a term, you will lose its constants, right? If you're derivating a constant, it will be getting 0. So when you're integrating, you will be summing up all its constants and put it as c. Okay. Hello. What is the need of integration? To find out many things like area under the curve and etc. V1. Hi. Now, these are some of the basic functions, basic formulas we'll be learning in this chapter of integration. The first formula is x power n dx integral. It states that x power n dx integral is equals to x power n plus 1 by n plus 1. This is plus c, where n is not equals to 0, because n is equals to minus 1 or 1, it will be undefined, right? Now, if in the differential part x square, let me write dx, dy by dx, it is 2x power x minus 1, right? 2 minus 1. This is exactly opposite to it, right? And integral of 1 is a constant x, is a variable x plus c. Now coming to cos x, it is positive of sin x. While differentiating this, we would be getting derivative of cos x would be minus sin x. Right? Now sin x is minus cos x plus c. Secant square would be tan x plus c. Cosecant square would be minus cot x plus c. And secant x tan x is equals to secant x plus c. Let me tell you, these are all the reverse formulas that you have learned from derivatives. And some of the more formulas we will see. E power x, it will never change. E power x is e power x, dx integral would be e power x plus c. And dx by x, this is an important thing to remember. 1 by x dx integral would be log of mod x plus c. And here, if you can see, a power x dx is equals to ax by ln a plus c. These are some of the most important formulas that you will need to remember while solving questions from this lesson. Okay. Now coming to types of integrals. We have definite and we have indefinite. Indefinite has no mentioned limits. You can see, while coming to definite, you have a starting point and you have a ending point. That's the only difference between a definite integral and a indefinite integral. Right. Now, how do we solve this? Let me tell you, or let me show you how do you solve this. First step, let us write each integral on its way. Integral 5x square dx minus integral. See, it's a constant, you can get it out, right? 8x dx plus integral 1 dx. Understood till here? Now let me integrate this. This is constant, you can get this out. This should be 5x cube by 3. Okay, this should be minus 8. X dx, we know the formula, right? X power n plus 1 by n plus 1. That should be x power square by 2 plus integral of 1 dx, which is x. Now coming to adding constants, plus c. Right? The derivative of 5x square would be 5x cube by 3 minus 8 into x square by 2 plus 5 into 1 dx, which is 5x plus c. Great. Now, if you can see this, you can cancel this out to foza. So this would be 5x cube by 3 minus 4x square plus 5x plus c. Now you would be asking, why am I using only one constant? I'm integrating three terms, right? X, 5x square, 8x and 5. Let me tell you, this should be a sum of all the constants, Nana. Right? This is a sum of the constants, which is a constant itself. Right? The C1 belongs to 5x square, the C2 belongs to 8x and 5x. This is C3. Okay? Great. Now let us solve the simple sum. The first step would be get this constant outside the integral. Would be 7 integral of sin x dx. We know the integral of sin x, which is minus cos x, right? Let me show you. Yeah. Sin x would be minus cos x. We can solve this. This would be 7 into minus cos x plus c. That's it. 7 minus cos x, 7 into, that should be 7 minus minus 7 cos x plus c. Understood? Hope everyone understood. Great. Now let us integrate this question. Now while you're differentiating, let me say sin 5x. If you differentiate it, it should be cos 5x, and the part inside the bracket you should also derive it, and in this case should be multiplicative because implicit functions, right? You should integrate the inside part also, but in this case we will be dividing it. We will be dividing the term, right? This would be, let me get this outside, 7 integral of cos 5x dx. Integral of cos x dx would be positive of sin x. Okay. Yep. So that should be 7. If I open this bracket, this would be sin 5x, and if I integrate the inside 5x, it would be by 5, right? Plus c. Got it? Hope everyone understood. Okay. This should be 7 by 5 sin x, 5x sin 5x plus c, which is the constant. Great. Understood everyone? We have removed the constant, then integrated this function and integrated the inside function, which is 5x, right? Okay, let's continue. Now coming to substitution method. It is nearly a you have learnt in differentiation. It's a type of it where we will, if you have a bigger function like this or any complicated function, we'll try to substitute the one function and the other function as the derivative of it, so that you can finally get the equation as u du. You can differentiate it easily, right? So we'll be doing this. For that, we'll be assuming u as some g of x. It should be g of x, and d of u, which is derivative of u, should be g dash x and dx. And if we supply both of that, this would be integral f of u du, which we can easily integrate, right? Come on, let's solve this. In this case, let us try putting 1 minus 2x as u. Now, let us differentiate on both sides. What would we be getting? 1 is 0, derivative of 1 would be 0, x would be 1, so it would be minus 2 dx is equals to du. Okay, but we have dx in the question, so let us just get dx. So dx would be minus 1 by 2 du. Okay, you understood till here. Now let us substitute these values in the above equation. That would be integral of 1 by 1 plus 2x is 1 minus 2x is u. Okay, now dx is minus 1 by 2 du. Let me get this constant outside, right? If I get this outside, this should be minus 1 by 2 integral of 1 by u du. Okay, now what is the integral of 1 by u du? Application of definition. Just a second. Okay, cool. Okay. Now what is the 1 by u du integral? It's log, right? Log of, yeah, it's where we have it. Yeah, it's log mod x plus c. Let us apply this. Log mod x we can't use x, we are using the term u, right? Plus c. Now if we apply 1 by 2, let us put the value of u, which is minus 1 minus 2x. Plus c. Hope you all understood this. In this we have considered 1 minus 2x as u, and then we differentiated it on both sides. And while differentiating, the constant differentiation would be, differentiation of a constant would be 0, and differentiation of minus 2x would be minus 2, in differentiation of x would be 1, and that is when we got minus 2 dx is equals to du, and dx is equals to minus 1 by 2 du. Then we integrated or substituted this whole value in terms of u and du. That would be minus 1 by 2 1 by u du. 1 by 2 du integral of, this is the formula. Right? And then we applied u. We open the brackets and we applied the formula or the consideration u is equals to 1 minus 2x. Hope you understood this, right? Let's take one more question. Now, integral of, okay, integral of 3x plus 4 dx. Let me consider 3x plus 4 as some u. Sorry. Now, let us differentiate it on both sides. what will be it? 3. Differentiation of x would be 1, right? 3 dx. Differentiation of 4 would be 0 since it's a constant, is equals to du. Okay, dx would be du by 3. Got it? Now, can we put this in the equation now? Cos, integral of cos u dx is du by 3. If I get this to the outside, it should be 1 by 3 integral of cos u. Right? This would be 1 by 3 sin u. Because integral of sin cos x, just me right, dx is equals to sin x plus c. Right? That should be sin u. And we know the value of u is sin of 3x plus 4. You cannot apply method of substitution to every form that you see. You have to see the both functions. One function is the derivative of other, and you can substitute the formula. Okay, cool. Now, let us solve this question, right? In the method of substitution, what can we use? You can see x square plus 1. If you differentiate it, you would be getting 2x, right? We can use that now. X square plus 1 is equals to u. Got it? Let us differentiate it. This should be 2x plus 0 is equals to, okay, let me write du also. X dx is equals to du. Right? What is dx? Dx. No, you don't have to write anything here because the form is already in 2x dx. 2x dx is equals to du. The only thing you need to do here is substitute the value of u and dx or du. That would be 2x dx. We know that value, which is u, cos u du. Got this, guys? We have assumed x square plus 1 to be a variable u. We have differentiated it and then we put up that value in the given question. So now we would be getting integral of cos x, which is sin x, that's equals to sin x or sin u plus c. Great. We know the value of u, which is sin of x square plus 1 plus c. Hope you all understood this. Just a second. Okay, cool. We have assumed x square plus 1 to be a u. We have differentiated it 2x dx while we got the du, and then we put up the value of du in the given question. 2x dx is equals to du. So integral of cos u du would be sin u, and the value of u would be x square plus 1. Right? Now coming to integration by parts. The formula is integral u dv is equals to uv minus integral of v du. How did we get this? Let me tell you. Did you know the uv formula of differentiation? U into v integral plus d by dx of uv is equals to u into dv by dx plus v into du by dx. Now if I integrate on both sides, that should be d by dx uv dx is equals to integral of u dv by dx plus integral of v du by dx. Now if you can open this, you will be getting this only, right? We would be getting uv is equals to you would be u integral of dv, right? We have a positive number, so it will be positive of v du. Right now, if we take this to, if we keep it and take this to the other side, it should be integral of u dv is equals to uv minus integral of v du. Okay. Now, where do we use this? It is used to integrate expressions where there exist different types of functions. If you have two or more than two functions, okay, no. Yeah, we have actually, in this we have, okay, we have to put C. Yep, in this we have. Okay. Now, it is used to integrate an expression where there exist two or more functions, right? Now, how do you choose u and v? It is an important thing to choose. You have to know how do you choose u and du. This can be done by a Lie rule, which states that this is in the increasing order, Nana. You should choose logs first, then inverse, then algebraic, then trigonometric, and then exponential functions. E power x, anything, sin x, cos x, algebraic would be 2x, x square, inverse would be a power minus 1 tan inverse or something. Logs would be logarithms, right? Now, how can we solve this? What should be integral of u dv? Let us choose u and dv first. Choose u and dv first. What should be u? U should be chosen by the Lie rule and dv is the remaining function. Based on the Lie rule, we are getting u as 2x, right? U as 2x and dv as sin x dx. So, (2x) is equals to u and sin x dx is equals to dv. Now, important thing to remember is we have to differentiate one function and integrate the one function. Which function would be derivating? We would be differentiating this function and integrating this function. It is an important thing to remember which one are you doing, right? If we do this, we'd be getting 2 dx is equals to du. Okay. Now, if we integrate this, let me write integral of sin x dx is equals to integral of dv would be v. Okay. This should be minus cos x is equals to v. Okay, you understood till here, right? Now, can we write this to du is equals to du is equals to positive 2 dx and minus cos x is equals to v. Now we'll apply the formula, uv formula, which is integral of u dv, integral of u dv is equals to u into v minus of integral of v into du. Let me change. Okay, this is the formula, right? Integral of minus v du. Now, let us substitute the values we have. That's equals to uv. What do we have? U. We have considered u as 2x. 2x into v. What is v? We have v as minus cos x minus of integral of, what is v? V is minus cos x and du is 2 dx. Understood till here? Okay. Now let us open this. This should be minus 2x cos x. This should be, if I get this outside, this should be positive. Sin x, let me get this, okay, positive of integral of cos x 2 dx. Okay, you understood till here. Now, if I get 2 to the outside, that should be minus cos x, sorry, minus 2x cos x plus 2 integral of cos x dx. That would be minus cos x, or let me write here, this should be minus 2x cos x plus 2 into, this should be integral of cos x would be indefinite, indefinite, no, mostly you will be getting a definite only, na? Yeah, cool, plus 2 sin x plus c. Hope you understood this. The first step, we have considered u and dv using the Liet rule, which states that u should be chosen in a order of logarithms, inverse, algebraic, trigonometry, and then exponential. So we have chosen 2x as our u and the other part as dv. Now in this part we have differentiated it, in this part we have integrated it. Now differentiating 2x, this would become 2 du is equals to dx, right? Now integration of sin x dx is equals to integral of dv. Integral of dv would be v and integral of sin x dx would be minus cos x. Okay. Now what we have done, we have put up the formula which we have, which is integral of u dv is equals to uv minus integral of v du. How did we do that? U, we know the value of u. We have considered u as 2x into, this should be v. V we have gotten due to different integration, which is minus cos x minus integral of what we have gotten u minus cos x into du is 2x. Opening the brackets, we have got minus 2x cos x plus 2 integral of cos x dx. Integral of cos x would be sin x. So this is the final answer we have received. Hope you understood this process. This is an important theory part from your integration lesson, integration by parts we call it. Now coming to one more question we'll solve. Integral of 4x cos 2 minus 3x into dx. How can we do it? Right? Let us consider u and dv. How can we consider u and dv using the Liet rule? It states that algebraic would come before trigonometry, right? So u is equals to 4x. Let me check. And dv is equals to cos 2 minus 3x dx. This part we would be differentiating it, and this part we would be integrating it. Now du is equals to 4 dx, right? If we differentiate it, du is equals to 4 dx. Then dx would be du by 4. Got this? We differentiated u is equals to 4 dx and we got dx is equals to du by 4. Now let us integrate this. Integral of dv would be v is equals to integral of cos 2 minus 3x dx. First let us integrate the cos 2 minus 3x, which would be sin x, sin of 2 minus 3x. Now we have to integrate the inside part also, right? If we integrate constant, that should be minus 1 by 3, right? Plus c if you want. So v is equals to sin of 2 minus 3x by minus 3. Now let us put up the formula, which is integral of u dv is equals to u into v minus integral of v into du. V into du, that's the formula, right? Let me check. See, uv minus v into du. Great, we understood this. So what did we get? Dx is equals to du by 4. And v is equals to sine minus 3 by minus 3. Okay, now let me open this. Okay, let us keep du is equals to 4 dx, right? Du is equals to 4 dx. Now uv, this should be uv minus integral of v du. What we have considered u is equals to 4x. 4x into, what is v? We have got as sine 2x minus 3 by minus 3 minus of integral of v du. What do we have as v? We have same, v as sine 2x minus 3 by minus 3 and du as 4x, 4 dx. Okay, let me solve this. This is 4 by 3x minus 4 by 3x into sine 2x minus 3. 4 by 3x minus 3. Okay, this should be right. You understood this part. Now if I open this, this would be minus minus, this would be positive 4 by 3 integral of sine 2x minus 3 dx, right? This should be minus 4 by 3 x sine of 2x minus 3. Now if I open the integration, this should be plus 4 by 3. Sine should be minus cos by 2x minus 3, the integration would be minus, sorry, just a second. Okay. Okay, 2 minus 3x guys, this was 2 minus 3x. Okay. Two minus 3x okay. Two minus 3x, 2 minus 3x, 2 minus 3x, should be 2 minus 3x by, this would be minus 3, right? Integral of 2 minus 3x inside integral would be minus 3. So if I open this, this would be minus 4 by 3 x sine of 2 minus 3x plus 4, because minus minus, 4 by 9 of cos of 2 minus 3x. Hope you understood this. Minus 4 by 3x sine 2x minus 3 plus 4 by 9 plus c. So let me tell you what we have done this again. We have assumed u using the Lie rule, which states what comes first, and then the remaining part it became dv. Now we have differentiated the u and integrated the dv, which upon differentiating and integrating we received dx is equals to du by 4 and v is equals to sine into 2 minus 3x into minus 1 by 3 plus c. Now we have applied the formula, which is integral of u dv is equals to uv minus of integral of v into du, right? Then finally we have put up the terms which we know, which is du is equals to 4 dx or uv is equals to integral of v du 4x into 2 minus 3x by minus 3, which is the inside integral of 2 minus 3x minus of integral of v du, v into du. Then upon solving, we have received this answer with a constant in itself. Okay. Hope you enjoyed this session, guys. Hope you have all enjoyed this session. If you enjoyed this session, I want to learn more. We are launching a sisyaai lead batch for the grades 8th, 9th, 10th, 11th and 12th. A course completed, crafted by the IITians. Now coming to why do you have to start early? No, you have mostly 8 years. Sorry, you have only 5 years in your hand if you're in 8th class, 4 years and 3 years if you're in 9th and 10th classes, right? So the exam which you're gonna write is of high competition. Nearly 13 lakh students appeared this year. Nearly 13 lakh students appeared this year. Now out of the 13 lakh students, merely 2.5 lakh of them went to the advanced level. JEE is a 2 test level, 2 levels, mains and advanced. 2.5 lakh people went to the advanced level. Out of those 2.5 lakh people, only thousands of them went to the IITs. Starting early would also give you a better time to manage. You would have many things to do, right? College, academics, extracurriculars and etc. And it will help you develop a critical thinking ability also. Now you would ask me who would teach you in this foundation course. Since the course is crafted by IITians, we believe these experts could only have taught you in this course. Now coming to syllabus, we will be covering everything starting from 11th and 12th JEE syllabus, starting from 0 and moving to advanced level, right? Now coming to our class, the classes would be started on 2nd June and it will be live on our SISYA class app, where we will be providing with live quizzes and live ranking system to continuously monitor your progress. And then coming to support or doubts, if you have, we have a AI 24/7 support where you'd be able to ask your question in the form of photo, message, voice, etc. Right? And then we'll be providing you with 1:1 mentorship if you have more theory or conceptual doubts or any doubts regarding your preparation. And then you will be able to contact your master teacher from morning to evening with a minimum and maximum waiting period of 2 minutes to 7 minutes. And finally, we will be providing you with a AI plus mentor collab, right? And finally coming to self-study. If your doubts are clear and you're ready to practice, we would be providing you with daily practice problems and digital study material, worksheets, okay? Now coming to testing level. After your pre-bed, it's time to test what you know. For that, we are conducting bi-weekly test and mock test and test series to completely monitor your progress. So guys, coming finally to the prizes. We have 8th grade, 9th and 10th for 39,999, 9th for 44,999 and 10th for 49,999. Coming to multi-class package, we have 8th, 9th and 10th for 89,999, 9th and 10th for 65,999 and 10th, 11th and 12th for 2 lakh rupees. There are no seats left for the final batches, and the seats for the remaining batches are getting completed. I guess only we have 18 to 20% of the seats left. Coming to that offer that we have, okay, just a second. Yeah, this special offer is only valid till the JEE. Sir, it is more. Okay. Coming to until this JEE series is live in YouTube, we will be providing you with a discount that is 8th and 9th for 14,999, 15,999 and 16,999. The multi-class packages would be around 39,999, 30,999 for grades 8, 9, 10, 10, 10, 9, 10, 10. So please hurry up and please enroll in this course, where the link you could find in the description, and you could please download the SISYA class app by scanning this QR code, or it is available both in the Play Store and App Store. Thank you for your time, guys. Hope you like this session. Please like, share and subscribe.